So friend, look at the question based on series of inverse trigo functions. We have to find the sum of the series tan inverse 1 by 3 plus tan inverse 2 by 9 plus tan inverse 4 by 33 like this till infinite number of terms. And options are given as pi by 6, pi by 4, pi by 3 and pi by 2. Okay. Now look how to solve this type of numerical. Here, first of all, we'll try to find out the nth term of the series. Okay, so look. So in the first term, it is tan inverse 1 by 3 and tan inverse 1 by 3 can be written as tan inverse of 1 divided by 1 plus of 2. Okay. In the second term is tan inverse 2 by 9, that can be written as tan inverse of 2 divided by 1 plus of 8 and 8 can be written as 2 cube. Okay. In the third term, it is tan inverse of 4 by 33. So tan inverse of 4 by 33 can be written as tan inverse of 2 square divided by 1 plus 32 and 32 can be written as 2 to the power 5. So we can write the third term as tan inverse of 2 square divided by 1 plus 2 to the power 5 like this. Okay. So this 1 can be written as 2 to the power 0 and this 2 can be written as 2 to the power 1. This 2 can be written as 2 to the power 1. Okay. So just look on the series. In the first term, at the numerator it is 2 to the power 0. In the second term, at the numerator it is 2 to the power 1. In the third term, at the numerator it is 2 to the power 2. So in the nth term, we can say nth term will be tan inverse of, at the numerator it is 2 to the power n minus of 1. Sure. And at the denominator, one should write because at the denominator in each term, 1 is there. Okay. Plus 2 to the power. Look, this 1, 3, 5, these are in what? AP with common difference 2. So we can say the nth term will be, this is 2n minus of 1. Okay, I think it is clear. Now, our intention to express this nth term, that is tan inverse of 2 to the power n minus 1 divided by 1 plus 2 to the power 2n minus of 1 as a difference of two tan inverse function. That is, we want to write this is in the form of tan inverse x minus tan inverse y. Okay. We know what is tan inverse x minus tan inverse y. Tan inverse x minus tan inverse y is tan inverse x minus y divided by 1 plus x into y. Look, 1 plus form is already there. So we have to split this 2 to the power 2n minus 1 into two form, two product or two factor. And difference of that two factor will be 2 to the power n minus 1. Look how it can be done. So we can write Tn as tan inverse of 1 plus this 2 to the power 2n minus 1 can be written as product of two numbers, that is 2 to the power n into 2 to the power n minus 1. Is it? And the difference of 2 to the power n and 2 to the power n minus 1 is nothing but 2 to the power n minus 1. So this 2 to the power n minus 1 can be written as 2 to the power n minus 2 to the power n minus 1. If you want to check it, just take common 2 to the power n minus 1 at the numerator. It will be 2 to the power n minus 1 into 2 minus 1, that is 2 to the power n minus 1. Got it? Okay. So Tn can be expressed as tan inverse of x. So consider this 2 to the power n as x and 2 to the power n minus 1 as y. So tan inverse x minus tan inverse y. So this is tan inverse of 2 to the power n minus tan inverse of 2 to the power n minus of 1. Okay. Now come to another interesting part. We already get the value of Tn. So if we substitute T1, that is n by 1, then what we will get? T1. This become what? Tan inverse of 2 to the power 1 minus tan inverse of 2 to the power 1 minus 1, that will be 0. So we will write this is 2 to the power 0 is 1. So now substitute n by 2. So T2 will be what? Tan inverse of 2 to the power 2 minus tan inverse of 2 to the power 2 minus 1, that is 2 to the power 1. So we can write T2 is equal to tan inverse of 2 square minus tan inverse of 2. Okay. Similarly, just substitute n by 3. Then we will get T3. So T3 is equal to tan inverse of 2 to the power 3 minus tan inverse of 2 to the power 2. So we can write this is 2 to the power 3 minus tan inverse of 2 to the power 2. Okay. And so on. Finally, we can write Tn as tan inverse of 2 to the power n minus tan inverse of 2 to the power n minus of 1. Look, the style to solve. Now, if we add this, what we will get? T1 plus T2 plus T3 plus Tn. These are the terms of the series. So, if we add from T1 to Tn, what we will get? We will get the values of Sn. So, this is Sn. Now, we must add the right hand side also. So, in the right hand side, this tan inverse 2, tan inverse 2, tan inverse 2 square, tan inverse 2 square, tan inverse 2 cube, like this, all are cancelled. So, this tan inverse 2 to the power n minus 1 also cancel. So, what will be remaining? Sn will be tan inverse of 2 to the power n minus tan inverse of 1. Now, what we need? We need S infinity, that is number of terms is infinity. So, substitute n by infinite, we will get S infinity. So, S infinity will be tan inverse of 2 to the power infinity minus tan inverse of 1. Okay. You know very well tan inverse of 2 to the power infinity means tan inverse of infinity minus tan inverse of 1 is nothing but pi by 4, we all know. So, tan inverse of infinity, again the result is pi by 2. So, this is pi by 2 minus pi by 4. So, what is the answer? The answer is pi by 4. So, pi by 4 is our required answer. Got it? And in the option B, pi by 4 is there. So, our correct option is option B. Okay, clear? So, in this way, normally we solve this type of numerical. This is a series of tan inverse. So, that is why we first find the nth term in terms of tan inverse. Then we express the nth term as tan inverse x minus tan inverse y. If it was cot inverse series, then we have to find first Tn in terms of cot inverse. Then we have to express Tn in the form of cot inverse x minus cot inverse y. If it is sine inverse series, then we have to express Tn as sine inverse, and then Tn has to be expressed in the form of sine inverse x minus sine inverse y. Okay, then consecutively we have to put n equal to 1, 2, 3, 4, 5, 6 until n in the expression of Tn. Then we will get Sn, and finally we have to put n as infinity to get S infinity. Understand? Clear? Okay, now come to the next question. So friend, now come to the question. We have to find the sum of the infinite series, and the series is cot inverse 2 plus cot inverse 8 plus cot inverse 18 plus cot inverse 32, like this till infinite number of terms, and options are given in the board. Now, to solve this type of numerical that is related with the cot inverse series, it will be better for us if we convert this in the form of tan inverse series, because applications of tan inverse series is easier than applications of cot inverse series. Okay, so cot inverse 2 can be written as what in terms of tan inverse? It is tan inverse of half. Okay, cot inverse 8 can be written as tan inverse of 1 by 8. Is it? Similarly, cot inverse 18 and cot inverse 32 can be written as tan inverse of 1 by 18 and plus cot inverse 32 is tan inverse of 1 by 32, like this till infinite. Now we have to identify the nth term of this series. To do this, we will think about each and every terms. Okay, so look, the first term is of the form of tan inverse 1 divided by 2 into 1, that is we can write 2 into 1 square. Okay, the second term can be written as tan inverse of 1 divided by 2 into 2 square. Is it? The third term can be written as tan inverse of 1 divided by 2 into 3 square. Is it? Because 2 into 3 square is 18. The fourth term can be written as tan inverse of 1 divided by 2 into 4 square. So in this way, we can arrange each term. So it is clear to us by looking each term that the nth term of this series will be tan inverse of 1 divided by 2 into n square. Now, we have to express this tan inverse of 1 divided by 2 into n square in the form of tan inverse x minus tan inverse of y. To do this, we'll first multiply and divide by 2 in the numerator and denominator of the inside the bracket. So this can be written as tan inverse of 2 divided by 4n square. Okay. Now, tan inverse of 2 divided by 4n square can be written as tan inverse of 2 divided by 1 plus of 4n square minus of 1. Look, we can write it. So, this tan inverse of 2 by 1 plus 4n square minus 1 can be written as what? Tn is equal to tan inverse of 2 divided by 1 plus 4n square minus 1 can be factorized in the form of 2n plus of 1 into 2n minus of 1. Basically, this 2n plus 1 into 2n minus 1 are x and y which we required. Okay. Now look, difference of this 2n plus 1 and 2n minus 1 is nothing but 2. So we can write this is equal to tan inverse of 2n plus of 1 minus 2n minus of 1 divided by 1 plus of 2n plus of 1 into 2n minus of 1. Okay. So Tn is basically equal to tan inverse of x minus y divided by 1 plus x into y. So what we can write? We can write Tn is equal to tan inverse of 2n plus of 1 minus tan inverse of 2n minus of 1. Okay. Now we will substitute n by 1, 2, 3, 4 respectively. So if we put n equal to 1, what we will get? We get T1, and T1 become tan inverse of 3 minus tan inverse of 1. Okay, just put n equal to 1 in both sides of this identity. So T1 will be tan inverse of 2 into 1 plus of 1, that is tan inverse of 3, minus tan inverse of 2 into 1 minus of 1, that is tan inverse of 1. Similarly, we get T2 is equal to tan inverse of 5 minus tan inverse of 3. Okay. Similarly, we get T3 is equal to, that is substitute n by 3, we get T3 is equal to tan inverse of 7 minus tan inverse of 5. Okay. So in this way, we will continue, and finally we will substitute n by n again, that is Tn is equal to tan inverse of 2n plus of 1 minus tan inverse of 2n minus of 1. Look, so what we will get? T1, T2, T3 and Tn. Okay. Now if we add, what we will get? T1 plus T2 plus T3 plus dot dot till Tn, that is Sn, and Sn will be, just we can cancel this tan inverse 3, tan inverse 5, tan inverse 7 like this. So what are remaining? It is tan inverse of 2n plus of 1 minus tan inverse of 1. We need what? We need S infinity. So substitute n by infinite. So we get S infinite is equal to tan inverse of 2 into infinite plus 1, that is tan inverse of infinity, minus tan inverse of 1. So what is the value of S infinity? Definitely tan inverse infinity is pi by 2 minus tan inverse of 1 is pi by 4. So in this case the answer is pi by 4. Okay, and the option is, yes, option is option B. Okay, so we can solve this numerical in this easy way. Okay, now come to the next question. So friend, come to the next question, that is we have to find the sum of infinite series cot inverse 1 square plus 3 by 4 plus cot inverse 2 square plus 3 by 4 plus cot inverse 3 square plus 3 by 4, like this till infinite. Okay, and options are given, which are as pi by 4, tan inverse 2, tan inverse 3, or none of this. Okay, now to solve this numerical, we'll convert this all cot inverse in the form of tan inverse first. So the first term can be written as tan inverse of 1 divided by 1 square plus 3 by 4. As we know, cot inverse of x is tan inverse of 1 by x. So the second term can be written as tan inverse of 1 divided by 2 square plus 3 by 4. Okay. Similarly, the third term is tan inverse of 1 divided by 3 square plus 3 by 4. Okay, till infinite. Now, try to identify the nth term of this series. Clearly, nth term of this series is Tn equal to tan inverse of 1 divided by n square plus of 3 by 4. Okay, now we have to arrange this tan inverse of 1 divided by n square plus 3 by 4 in the form of tan inverse x minus tan inverse of y. So look how we can arrange. This is tan inverse of, just first write here 1, because tan inverse of x minus of tan inverse y is equal to tan inverse of x minus y divided by 1 plus of x into y. So we should write here first 1 plus, it is n square minus 1 by 4, and at the numerator 1 is there. Okay, so obviously now Tn can be written as tan inverse of 1 plus n square minus 1 by 4 can be factorized in the form of n plus half into n minus of half. Okay, and it is clear to us this 1 plus n plus half into n minus half is of the form of 1 plus x into y. So the numerator must be in the form of x minus y, that is n plus of half minus of n minus of half. Okay, and look, n plus half minus of n minus half is nothing but 1, which we have already at the numerator. Okay, so this whole expression can be written as tan inverse of x, that is n plus of half, minus tan inverse of y, that is n minus of half. Okay, so we express Tn in the form of tan inverse of x minus of tan inverse of y. Now we have to put n equal to 1, 2, 3, 4 consecutively. Okay, so look, T1 is what? Obviously it is tan inverse of 1 plus of half, that is tan inverse of 3 by 2, minus tan inverse of, this is 1 minus of half, that will be half, so tan inverse of half. Okay, so we get T1 as tan inverse of 3 by 2 minus tan inverse of half. Now if we substitute n by 2 in this given identity, so T2 will be tan inverse of 2 plus of half, that is tan inverse of 5 by 2 minus tan inverse of 2 minus of half, that is 3 by 2. Okay, clear? Similarly, substitute n by 3. So T3 you will get, it is tan inverse of 3 plus of half, that is tan inverse of 7 by 2. So we will write tan inverse of 7 by 2 minus tan inverse of 5 by 2. Okay. In this way we will continue till we will substitute again n by n. That is, we will get Tn is equal to tan inverse of n plus of half minus tan inverse of n minus of half. Look. So we get T1, we get T2, we get T3 till we get Tn. So if we add this, the left hand side will be Sn. Okay. So just adding it, the left hand side, that is T1 plus T2 plus T3 plus dot dot till Tn will be Sn, and the right hand side tan inverse 3 by 2, tan inverse 3 by 2, tan inverse 5 by 2, tan inverse 5 by 2, these are diagonally cancelled. So the cancelling tricks are this. So what are the remaining at the right hand side? It is tan inverse of n plus of half minus tan inverse of half. Is it? So we have to find the value of S infinity. So substitute n by infinite. Therefore, S infinity will be tan inverse infinity minus tan inverse of half. Okay. What is tan inverse infinity? It is pi by 2. So pi by 2 minus tan inverse of half. This give cot inverse of half. We know tan inverse of x plus of tan inverse cot inverse of x is equal to pi by 2. So pi by 2 minus tan inverse half, that is pi in the form of pi by 2 minus tan inverse of x will be cot inverse of x. Okay, that is cot inverse of half. And cot inverse of half can be written as tan inverse of 2. So our answer should be tan inverse of 2. And look, in the option B, the answer is tan inverse of 2. Okay, very easy, I think. Now come to the next question. Find the sum of the infinite series tan inverse of 2 divided by 1 minus 1 square plus 1 to the power 4 plus tan inverse of 4 divided by 1 minus 2 square plus 2 to the power 4 plus tan inverse of 6 divided by 1 minus 3 square plus 3 to the power 4 till infinite. Okay, and options are given in the board. Now to solve this numerical, obviously we will try to find the nth term first. Okay, so it is clear to us after looking this series that Tn will be tan inverse of 2 into n divided by 1 minus n square plus n to the power 4. Is it? So this is the Tn, because if we put n equal to 1, we'll get the first term. If we put n equal to 2, we'll get the second term. Okay. Now we have to arrange this Tn in the form of tan inverse of x minus of tan inverse of y. Okay. So how we can arrange? Tan inverse of this 1 minus n square plus n to the power 4 can be written as 1 plus n square plus of n into n square minus of n. Okay. So look, this is 1 plus x into y. And obviously the numerator will be x minus y form, that is n square plus of n minus of n square minus of n form. Okay. And n square plus n minus of n square minus of n is equal to 2n. So is it match? So we can write Tn is equal to tan inverse of n square plus of n minus tan inverse of n square minus of n. Okay. Obviously, now we will put what? N equal to 1, 2, 3, 4 consecutively, and then we will add, we will get Sn, and finally we will substitute n by infinite. Is it? So what is the value of T1 now? So here T1 will be tan inverse of 1 square plus of 1, that is 2, minus tan inverse of 1 square minus of 1, that is 0. So we write here 0, tan inverse of 0. Similarly, T2 will be tan inverse of, it is 2 square plus of 2, that is 6. Okay. minus of tan inverse of 2 square minus of 2, that will be 4. That will be 2. Again, T3 will be tan inverse of 3 square plus of 3, that is 9 plus of 3 will be 12 minus tan inverse of 6, because 3 square minus of 3 will be 6. Okay. So, in this way, finally we will put Tn, and Tn is tan inverse of n square plus of n minus tan inverse of n square minus of n. Okay. Look. So, we write T1, T2, T3 in this way Tn. So, when we will add, what we will get? We will get Sn, because T1 plus T2 plus T3 dot dot till Tn is Sn. And when we will add the right hand side, in this sense the terms will be cancelled. So, the result will be tan inverse of n square plus of n minus tan inverse of 0. Okay. So, what is S infinity? Just substitute n by infinite. We will get S infinite is tan inverse of infinite minus tan inverse 0 is 0, you know. So, what is S infinite? Finally, S infinite is equal to pi by 2, as tan inverse of infinite is pi by 2. Okay. So, our answer is pi by 2, and it is also in option B. So, our option is B. Okay. Clear? I think very easy. Now, come to the next question. So, look at the question. We have to find the sum till infinite. The series is sine inverse of 1 by root 2 plus sine inverse of root 2 minus 1 by root 6 plus sine inverse of root 3 minus root 2 by root over 12 plus dot dot sine inverse of root n minus root n minus 1 divided by root over of n into n plus 1 plus dot dot till infinite. Okay. And options are given. Now, to solve this numerical, we have to first identify Tn, and it is clear that in the series the nth term is this. Okay. So, Tn we can directly written as sine inverse of root n minus root over of n minus 1 divided by root over of n into n plus 1. Okay. So, if we check it, just T1, substitute n by 1, we will get sine inverse of 1 minus 0 divided by 1 into 2, that is 1 by root 2. Look, it is 1 by root 2. Similarly, if we check by n equal to 2, we will get the second term here. So, this is the nth term, it is confirmed. Now, we have to express this in the form of sine inverse of x minus of sine inverse of y. Okay. So, trying to express this in the form of sine inverse of x minus of sine inverse y, this can be written as sine inverse of root n divided by root over of n into n plus of 1 minus root over of n minus 1 by root over of n into n plus of 1. Okay. Clear? So, Tn is equal to sine inverse of, we can write this first part as 1 divided by root over of n plus root over of n into square root of n divided by n plus of 1. Okay. Minus, this is 1 divided by, the second part can be written as 1 divided by root over n plus 1 into square root of n minus 1 by n. Okay. So, look, Tn is sine inverse of 1 by root n into square root of 1 minus 1 divided by root over n plus 1 whole square. Because if we simplify 1 minus of 1 divided by root over n plus of 1 whole square, it will get n divided by n plus of 1. Okay. Minus 1 divided by root over of n plus of 1 into 1 minus 1 by n, and 1 by n can be written as 1 divided by root n whole square. Now, This is obviously in the form of sine inverse x minus sine inverse y. Why? Sine inverse of x is 1 by root over n into root over of 1 minus y square, y is 1 by root over n plus of 1 minus y into root over of 1 minus of x squared. So, we can write Tn as sine inverse of 1 by root n minus sine inverse of 1 by root over of n plus of 1. Okay. Now, we will put n equal to 1, 2, 3, 4 consecutively and we will get T1, T2, T3, T4 and finally we will write Tn and we will add, then we will get Sn. Okay. So, look, T1 is sine inverse of 1 minus sine inverse of 1 by root 2. That is, just we put n equal to 1 in the identity Tn is equal to sine inverse of 1 by root n minus sine inverse of 1 by root over n plus 1. So, when we substitute n by 1, we get T1 as sine inverse of 1 divided by root 1, that is 1 minus sine inverse of 1 divided by root over of 1 plus of 1, that is 1 by root 2. Okay. So, in this way T2 will get sine inverse of 1 by root 2 minus sine inverse of 1 by root 3. Similarly, T3 will get sine inverse of 1 by root 3 minus sine inverse of 1 by root 4. So, in this way, we can put n equal to n. So, Tn will be sine inverse of 1 by root n minus sine inverse of 1 by root over n plus of 1. Look carefully. Just in Tn, we put n equal to 1, 2, 3 consecutively and so on. Finally, we write Tn here directly. Okay. So, if we add this, we will get the left hand side will get Sn because T1 plus T2 plus T3 dot dot till Tn is Sn. And in the right hand side, we can cancel in this way. Sine inverse 1 by root 3, sine inverse 1 by root 3, sine inverse 1 by root 2, sine inverse 1 by root 2. Similarly, sine inverse 1 by root 4 like this. So, in this way, we can cancel the all term excluding sine inverse of 1 and sine inverse of 1 divided by root over n plus of 1. Is it? So, what is Sn? It is sine inverse of 1 minus sine inverse of 1 divided by root over of n plus of 1. Okay. Now, what is S infinity? As we have to find S infinity, so just substitute n by infinity. So, substituting n by infinity, we get S infinity as sine inverse of 1 minus sine inverse of 1 by infinity. Okay. So, what is the value of sine inverse of 1? It is pi by 2 minus sine inverse of 1 by infinity means sine inverse of 0 and sine inverse of 0 means 0. So, our answer is pi by 2 minus 0, that is pi by 2. So, this is our answer. So, sum of this infinite series is pi by 2 and this is in option C. So, option C is the correct answers. Okay, clear? Now, come to the next type of question.